In this tutorial, I'm going to show you how we can do mediation analysis in R. This video has two methods. The first method is that I'm going to show you the 3 regressions based on Baron Kenny's paper. And I'm also going to show you how we can use the mediate function in the mediation package in R to calculate the 95% confidence interval. And there's another method, and I'm going to show you how we can write the function for the bootstrapping for the confidence interval in R from scratch. So let's jump into the first method. So the first method I'm going to show you that how we can just like do the 3 regressions based on Baron and Kenny. So what are those 3 regressions? So basic idea is that in the mediation analysis, we first observe that there's a relationship between IV and DV, and then we try to find a mediator to explain the relationship. Therefore, the first regression we're going to do is that we're going to regress the X on the Y, and then the second we're going to regress the X on the N, namely the mediator, and finally we're going to regress the X and M on the Y. And so now we got 3 regression coefficients, the C, the A, and the B. And also in the third regression, we also have a C apostrophe. To better explain the basic idea about mediation, here is a hypothetical study. So suppose that you observe that higher temperatures will lead to more ice cream sales. And then you try to explain this observed effect. You said, okay, maybe when temperature is high and people really would like to have some frozen desserts. So the need for frozen dessert is the reason why the temperature leads more ice cream sales. I mean, you might find this example funny, but I mean, this example serves a purpose to explain the basic idea about mediation analysis. So for this example, we need to have 3 regressions. Yes, we regress the temperature on the cells. That's first regression. We regress the temperature on the need for desserts. So the second regression. And then we regress the temperature and need for desserts on the cell. That's the third regression. Okay, now I'm going to jump to R to show you how we can do these 3 regressions. This is the R code I write it as an arc markdown. And so the first part, we're going to read the data from GitHub. So how the data looks like, let me show you in the Excel. So this is how the data looks like. That's X variable, which is the temperature. M is need for desserts, is on a 0 to 6 point scale. And the Y is the ice cream sales. I'm going to post this data down below in this video. So there will be a link down below in this video to link to this data set. So you can do some practice. Just remember that this data set is a hypothetical data set. So we read the data into as mediation data, and then we can print it out. So this is, I mean, you print this result. So I just did it earlier. So I mean, we can do it again. So I can see that this is the temperature, this is the mediator, need for dessert, this is the ice cream sale. So that's the basic idea of the data. And we're going to do the first regression. Let me just clean up a bit. So you can do the first regression is the C part, yes. So that's the basic effect, the temperature on the cells. We can run this session. So this is the regression coefficient for the X to Y, and we run it again for the X to M, the second regression. That's the A path. So we can see that, okay, both the C is significant and also the A is significant, yes. And then we're going to regress the X and M on the Y. That's our B path. So as you can see that the mediator on the Y is significant. So that means that basically both A path and B paths are significant. So that's required to establish a mediation effect. So basic idea we can report. I mean, if you are reporting a mediation analysis, you can just report in this way. This is A path, this is the B path, and this is the original C, the first regression, and this is the C apostrophe, namely the third regression, that the temperature and the mediator on the Y So basically, based on Barrow and Kenny, we basically are done for the mediation analysis. But when you read the most recent research, you can see that most people report the confidence interval. So what is the confidence interval? The confidence interval basically try to test the A and B, you time them together as the indirect effect. So you try to test whether the indirect effect is significant or not. In generally, we do that use the bootstrapping. So bootstrapping is a non-parametric method based on resampling the data with replacement. And you've done it many times. Typically, we do it 5,000 times. And then you have 5,000 data points of the indirect effect. And then you can kind of like use this 5,000 data point as a way to calculate the confidence interval. The problem is that how can we do that? Earlier we have 3 regression, yes, and if you time the A part, we can do this part. So if you do the time the 0.033 and times the 2.993, then you will get the indirect effect of 0.097. So that's our indirect effect. But we know that we only have like 1 data point, but we need like 5,000 of them. How can we do that? The thing we can do is that we can use a package called Mediation. So you do not have the package, you can install that. So we include this package into our current R programming environment. And then you need to use the function within this package called mediate function. And this is our APAR function. So basically we need to use some statement from the 3 regressions. So this is our APARs. So what is APARs? APAR basically is what we just store here. Yes, our APARs is the X regression on the M. So this is the APARs, and then we are our B pars. We are going to tell that we are going to simulate 5,000 times, and then we tell that the treatment is the X, our X variable, and the mediator is the M. And we're going to tell that we're going to use the non-parametric bootstrapping. And then we can show the result. Okay, so let's run that. So you will do it like 5,000 times, so it will take a while. So this is the output, and I'm going to shift to the PDF. So as I mentioned, I wrote this in a ARC Markdown, so you actually can like print it as PDF. So let me shift to the PDF, and I think it looks better in the PDF. So basically, this is what I just show you in the R Studio. So this is we include the library, and then we write out the function. So this is the output. As you can see that there's a few outlines of output here. So the first one is called ACME. So what ACME means stands for the average causal mediation effects. So basically it's our indirect effect. The A times B, we did it earlier, yes. We did it like the A times B. You time the 0.03 times 2.93, you will get the 0.097. So that's our indirect effect. So you can see that 0.097, 0.09748. So that's the same. So that's our indirect effect, A times B. And the AD is the average direct effect. So it's a C apostrophe, namely the C in the 3rd regression statement. So it's the 0.0022. So that's exactly the same. Yes, the C apostrophe. So namely here, the C apostrophe here. And then this is total effect. This total effect basically is our C, the first regression. So the 0.09977. So that's the first regression. Yes, our C, 0.09977. And so, so basically all this information are not new. The only thing actually we need is the indirect effect, the confidence interval. So this is like it provide you a 95% confidence interval for the indirect effect. So remember the first line output is our indirect effect, yes. So this is a lower bound and this is the upper bound. The funny thing is that the upper bound only has two decimals, so that's a bit funny. I don't know how to make two like more decimals, but you see that since that the 95% interval doesn't include a 0, it means that the indirect effect is significant, so the A times B is significant. Lastly, there's another output called proportional mediated. Basically, this is the ACME divided the total effect. The total effect is our C, yes. So it's A times B divided the C. The first C is which is from the first regression. So I think that's it for the method one. So we can use this package to provide us the computed interval for the indirect effect.